Hi YouTube. In this video, I will be explaining a series circuit. I will be explaining the rules which apply and the formulas and equations that's involved with a series circuit. Seen on the left-hand side of the screen here is an example of a series circuit. These are the resistors of the loads. These resistors here are all in series. Now, on the right-hand side of the screen is an example of a parallel circuit. These resistors are all in parallel. Now, this big circuit seen here is called a combination circuit or a series parallel circuit. Some of the resistors or loads in this circuit are in parallel and some of the resistors and loads are in series. That's what gets its name from combination circuit or series parallel circuit. Now, in this particular video, we will specifically be dealing with a series circuit. So before we get started with the series circuit, I want to talk about some letters that you may see in an electrical schematic when dealing with a series circuit. So you may see the letter E, which stands for electromotive force, known in the electrical field as voltage. You may see the letter I, which stands for intensity, better known in the electrical field as current, which is measured in amps. You may see the letter R, which stands for resistance, which is measured in ohms, and you may see the letter P, which stands for power and is measured in watts. Okay, now let's get to the rules which apply in a series circuit. First of all, in a series circuit, there's only one path for current to flow. So current leaves the power source, travels through the conductor, travels through the loads of the resistors, and back to the power source. There's only one path for current to flow. So, since there's only one path for current to flow, at every given point of the circuit, the current has the same value. So at the power source, the current has the same value as the current at the resistor 1, at resistor 2, at resistor 3. The current is the same at every point of the circuit. Now, the voltage drops. As for voltage, the voltage drops. The sum of the voltage drops equals the total voltage. As for the resistors, the sum of all the resistors equals the total resistance. As for the power, the sum of all the power throughout the circuit equals the total power. Now let's look at it in depth. First of all, let's look at how the current works in a series circuit. So the total current is equals to I sub 1, which is equals to I sub 2, which is equal to I sub 3. So the current is the same at every given point of a series circuit. So in this series circuit, the current equals 2 amps. So the current is 2 amps as it passes through the first resistor. The current is 2 amps as it passes through the second resistor. And the current is 2 amps as it passes through the third resistor. And the current is 2 amps at the total at the power source. Okay, now let's take a look at the voltage and what happens to it in a series circuit. So the sum of all the voltage drops equals the total voltage. So the voltage drop at the resistor 1 is 30 volts. The voltage drop at resistor 2 is 40 volts. The voltage drop at the resistor 3 is 50 volts. So when you add them all up, 30 volts plus 40 volts plus 50 volts, the total voltage at the power source is 120 volts at this point. Okay, let's look at the resistors. Okay, the rule is in a series circuit is the sum of all the resistors equals the total resistance. So resistor 1 is 15 ohms, resistor 2 is 20 ohms, and resistor 3 is 25 ohms. So the sum of all three resistors, 15 ohms plus 20 ohms plus 25 ohms, the total resistance is 60 ohms at the power source. Okay, let's look at the power. Okay, the power is what's consumed as the current passes through a resistor. So, okay, the power here is 60 watts. The power through resistor 2 is 80 watts, and the power through resistor 3 is 100 watts. So when you add them all up, 60 plus 80 plus 100 is 240 watts at the power source. Also, if you know two of the components, like maybe you know the amperage and you know the voltage, you could use Ohm's law to figure out the actual third value of something. For example, if you knew the current is 2 amps and you knew that the resistor equals 15 ohms, you can figure out what the voltage at resistor 1 is by using Ohm's law. E sub 1 is equals to I sub 1 times R sub 1. So E sub 1 will be equals to 2 amps times 15 ohms, which E sub 1 is equals to 30 volts. So you could use Ohm's law at any given point. You could use Ohm's law to find the power. You can use Ohm's law to find the power by using, if you knew what E was, you know that E is 30 volts, and you know that I sub 1 is 2 amps. You can use Ohm's law and figure out what the power is. So if E sub 1 is 30 volts and I sub 1 is 2 amps, you can use this formula right here to find out what the power is, because you know what E sub 1 is and you know what I sub 1 is. P would be equals to 30 volts times 2 amps, and P is equals to 60 watts. So you can use Ohm's law to figure out, as long as you have two knowns, you can use Ohm's law to figure out a third value that you don't know. So I hope that you find this video helpful and useful. Thank you very much.